Hi class, this is Professor Smith. I'm going to be doing a review on the sample test for sample test 2. Question 1, an aptitude test to design and measure the leadership abilities of test subjects. You can't see it written on the screen. I'll see if I can move it a little bit. Suppose that the scores are normally distributed with a mean of 560 and a standard deviation of 120. The individuals who exceed 750 on the test are considered potential leaders. What proportion of the population are considered to be potential leaders? So let me just read that again. So an aptitude test to design and measure the leadership abilities of the test subject. Suppose that the scores on the test are normally distributed with a mean of 560 and a standard deviation of 120. The individual who exceeds 750 are considered potential leaders. So let me go out to Word so I can capture the information as if I were writing it down on a piece of paper. So in this problem, I've written down that the mean is 560, the standard deviation is 120, and we want to determine if their score exceeds 750. That means that they are a potential leader. So what we're going to do is we're going to find the z-score that corresponds to exceed 750. So z is equal to x minus mu. You know what, this is in text mode, so let me change the style. Back to now. So z is equal to x minus mu all over sigma. So x minus mu divided by sigma. And so then we substitute in those values, and we can find the z-score that corresponds to x equal to 750. So it's going to be 750 minus the mean of 560 divided by the standard deviation of 120. So we'll go out to the ALEKS calculator and capture that. So exceed 750, that's our x-score, minus 560, which is our standard deviation, divided by, minus 560, which is the mean, and divided by the standard deviation. And so that gives us a z-score of about 1.583. So that 750 is about 1.5 standard deviations above the mean of 560. So we want to find the probability that it exceeds that. So exceeds means greater than. However, the probability key only gives us less than or equal to. So we want the right side, so we need to do 1 minus. And so when we find 1 minus that z-score, we get 0.056. And they tell us to round our answer to 4 decimal places. So it's 0.0567. A small jet can carry up to 44 passengers and 3 crew members. There is a weight restriction of the 900 pounds on board. The combined weight of each passenger or crew and his luggage has a mean of 198 with a standard deviation. What is the probability that the weight limit will be exceeded when there are 44 passengers and 3 crew members on board? You know what? I think this is sample sum. Yeah, it is. So we're going to skip this one. An employer interviews 9 people for customer service positions in a company, and 4 of the 9 are women. If all 9 are qualified, how many ways can the employer fill the customer service position if exactly 2 are women? So we got 9 people for 6 customer service positions, and 4 of the 9 people are women. If all 9 are qualified, in how many ways can the employer fill the customer service position? So we want to find out how many ways. Well, if there's 6 customer service positions and I want 2 of them to be women, then that means there's going to be 4 left that are going to be men. So let's take a look at doing that computation real quick. So I'm going to go out to Word. Alright, so since there's 6 customer service positions and we want to see and how many ways we can fill it with 2 women, then we're going to take a look at the number of women in the that they have. So let me go back out there to capture that. And 4 of the 9 are women, so 4 are women. Okay. So from the 4 women, I want to choose 2. So it's going to be 4, choose 2. Those are representing the women. And then I want to have 4 men left. And if there's 4 women out of 9 workers, so 4 out of 9, then 5 of them have to be men. So times 5, choose 4. And remember we said that whenever we have the combination that differed by 1, 5 choose 4 is just going to be 5. So 4 choose 2 is 4 factorial divided by 2 factorial times 2 factorial and times 5 for the 5 choose 4. And then that 4 factorial can be expanded out to 4 times 3 divided by 2 times 1. And the 2 times 1 is 2, and 4 goes into 3 2 times. Excuse me, 2 goes into 4. This 2 will cancel with the 4. And so you'll just have 2 times 3, which is just 6. So there's 6 different ways that will happen for this first one. And then I've got to multiply that expression by 5. So this here represents 4 choose 2. And then the 5 choose 4 was 5. And so we multiply the 6 times the 5, and then we get 30. So 30 ways that can happen. Let Z be the standard normal random variable. Use a calculator provided to determine the value of these. So remember in class when we had a tweener, we took the probability of the right minus the probability of the left, and that will equal 0.2414. So I'll go ahead and do that on the calculator. So I'm going to find the probability of the right guy, and the right value is negative 0.64. Okay, minus the probability of the left guy. And the left guy is just the letter C, and so it won't let me put that in, but at least you can see what I would be typing out. And that's going to equal, and that's going to equal that 0.2414. Okay, so that'll equal on this side 0.2414. So I'm going to interchange these two, so I'm going to put here the 0.2414. And that will give me the probability that Z is less than C. So let's go out and draw a picture of that. So I attempted to use the draw tool in Word to make this symmetric bell-shaped curve. It doesn't look very symmetric. But anyway, we had that the probability that Z was less than C was equal to 0.019. So wherever I put that C, the area to the left is 0.019, so that's small. So it'll probably be over here, not probably, but it will be a value over here on the left. Because that means that the area to the left of that will be, let's see if there's a little paint tool that they might have in here that I can paint. You know what I need? Paint, the paint program. Oh, well, don't laugh at me. You'll just have to imagine that it's the area to the left is going to equal 0.019. So that means this little area right here to the left will equal that 0.019. Well, I need to know the area to the right in order to get the Z-score. So in order to find this value here, I've got to know what that equals. So even though I know that this value here is equal to 0.019, so I'm just using a little text box to show that 0.019. Matter of fact, I'm not sure if it was 0.019. Let me double check. Here it is. I'll just 0.0197. 0.0197. So it's saying that this area here on the left is 0.0197. So if this area to the left is 0.0197, I need to know the area to the right in order to get the Z box. So to get the area to the right, I'm going to do 1 minus. So I'll go back out here and use the ALEKS calculator and do 1 minus this, and then find the Z score that corresponds to that area to the right. And so I'll hit the Z box, and I want the Z score for 0.9803, and that will tell me that it's negative 2.06. I think they want it to 2 decimal places. So I have negative 2.06. So that's the value that they have. Suppose that we've decided to test Clara, who works at the Psychic Center, to see if she really has psychic abilities. While talking to her on the phone, we'll thoroughly shuffle through a deck of cards. There's 52 cards. You can't see them on the screen, but it says 52. And they tell you that there's 13 hearts, spades, diamonds, and clubs. I'm going to draw 1 card at random, and we'll ask you to name the suit, if it's a heart, spade, diamond, or club, of the card we drew. After her guess, we'll return the card to the deck, thoroughly shuffle, and draw another card, and get her to guess the suit of the second card. And we'll repeat the process until we've drawn a total of 18 cards and gotten her suit guesses. Estimate the number of cards in the sample for which Clara guesses correctly by giving the mean. So they want us to find the mean of this, and then they want us to quantify it by finding the standard deviation. And so it turns out you're either going to guess the suit right or guess the suit wrong. So the probability of guessing the suit right is 1 out of 4, and so I'll capture that in Word. And then the probability, so we have here that the probability of success, which is guessing the card right, is 1 out of 4, or 13 out of 52 when you reduce it is 1 out of 4. And not getting it right is 3 out of 4. So the average is going to be given by n times p, where n is equal to the number of times you're going to shuffle the deck of cards for Clara. If you took 18 times 1/4, that's the same as 18 divided by 4, or 9/2, which is equal to 4.5. If you were to go out onto the ALEKS calculator and do 18 divided by 4, you would get 4.5 as well. So that's how you find the average. And then to find the standard deviation, it's equal to the square root. And so let me use the math type to capture that. So it's equal to the square root of n times p times 1 minus p. Similar to the formula when we're doing the sampling distribution, not quite, but a little bit. All right, and so this is equal to 18. So we'll take the square root of 18 times 1/4, or you can do 0.25 times 3/4, or you can do 1 minus 3/4. Either way will work. All right, and so we'll do that computation out on ALEKS. I wonder if it'll let me copy this. Let's see. I doubt it. Control C. I have this funky laptop that you have to do the mouse just right to capture the goodies there. And let me move this screen so you can see what I typed in. So you have the square root of 18, 1/4, and 3/4. All right, so let me go ahead and copy that. Control C. Let's just see if ALEKS is going to be nice to me. Thought not. Times 1/4. Oh dear, that looks like a decimal, doesn't it? Yeah, it does. All right, times 3/4. Hey, Be nice. Oh my goodness. What the heck is happening? Oh, I'd used. I'm using the parentheses keys on my key laptop instead of the parentheses key on Alex calculator. I'm having issues, as you can clearly see. It happens to you too, huh? It doesn't like I have all this stuff open. Yep, it's like mad. Let's try that one more time. Oh wow. Undo. It won't let me clear that. Okay. How about that? The clear button works. All right, 18. Don't use the parentheses on your keypad, Donna. 1/4. And then 3/4. Uh-oh. All right, so we take the square root of those guys, and you get 1.837. So let's put in the 4.5 and 1.837. So 4.5. And then I think this one they want to 3 decimal places. Okay. So 1.837. 1.837. So then we'll stop here, and I'll do another movie to finish up the rest. So what I'd like to do is, should I submit it? Nah. Alrighty. Thank you so much. I'll submit it at the end so you can watch the very last movie and see how well we did. Okay, bye.